in the last video, we have learned what is the uniformity coefficient, and we have find that uniformity coefficient after plotting the gradation curve. You have also learned how to plot this gradation curve for any type of soil. And based on this gradation curve, we have find the effective size D10, D30 and D60. And from here we have find the uniformity coefficient, that is Cu, by this formula, that is D60 by D10. We have also learned that when Cu is greater than your 5, or you can say if Cu is greater than 4 or 6, this is for sand and this is for gravel. In that case we are taking average as 5, then this soil is uniformly graded. Okay, now in this lesson we will continue further. Well, there are one more parameter or one more characteristic of this gradation curve. This curve is known as your gradation curve. Okay, that is known as your coefficient of curvature. Okay, this is another characteristic of this gradation curve. And how to measure this coefficient of curvature? This is measured by D30 square divided by D10 times D60. You know what is D30? That is, if this is the percentage of passing, then this is 30% passing, and D30 represent the size corresponding to this 30% passing. Okay, similarly this is D10 and this is your D60. Okay, and from this coefficient of curvature or CC, we can also define whether the soil is well graded or poorly graded, just like your coefficient of uniformity. Okay, so if CC is within this limit, in that case the soil is known as well graded soil. Okay, so that's all about your gradation curve. Now let's have some exercise based on this gradation curve. Okay, let's say this is your curve, this is the curve, and this is percentage of passing, and this is arithmetic, and this is in log scale, and this represent your size. Okay, and as per your size, the limit for your cobble was 80 mm, for gravel it was your 4.75 mm, for sand it was your 0.075 mm, and for clay and silt it was below 0.075 mm. So if we simply divide this into different sections like this is for, let's say, clay, this is for sand, this is for gravel, and this is for your cobble. Okay, this is 0.075, this is 4.75, this is your 80. Okay, so this is 80, and this represent cobble, this represent gravel, this represent your sand, this is your clay and silt. Now you have given a curve like this. Let's say this is the gradation curve. Okay, let's say this is the gradation curve. Now can you tell me what is the nature of this curve? Well, this is well graded because the particle size ranges from this 0.0, let's say 0.065 to up to, let's say, this is your 85. Okay, so in this soil you have all type of particle. Okay, that's why this is uniformly graded soil. Now again have another curve. Let's say this is So what is the nature of this curve? Here you can say that the size only varies from, let's say, 0.075 to your 0.45, and it is totally within this sand zone. So we can say that this is your poorly graded sand. Poorly graded sand. Just like that, take another example of this curve. Okay, let's say this is another curve. This is another curve. Here the specialty is in this zone or in this gravel zone, you can see that the curve is almost flat. That means there is no particle size. From this point to this point, everything has passed. There is no particular size within this range. That's why it is flat or parallel to the log axis. Okay, so what is the name of this type of curve? Here you can see that from this 4.75 to 80 mm, the particles are totally missing, or there is a gap in particle size. That's why this is known as gap graded soil, and the soil is here. You can see this is your sandy cobble sand. Cobble and sand, both are present almost in equal proportion. So we will call it gap graded cobble sand. So what are the main three things we have discussed here? First one is your well graded soil. First is well graded soil. Second is your poorly graded soil, and third one is your gap graded soil. So in well graded you will get particle like this. In poorly graded you will get only particular range of particle, for example here poorly graded sand, and in gap graded you will get first the big one, then the middles are missing, then you are getting the smaller one. Okay, so this is the difference between these three things. And there are one more parameter which you can describe for your coarse grained soil. Till now whatever we are discussing also related to your coarse grained soil or the soil particle which are greater than 0.075 mm in size. Okay, so let's consider the gravels. Okay, 20 mm gravel like this. Okay, so you can arrange all this gravel like this one by one, and here you can see there is a void in this region. These are the void. But if you arrange like this, now arrange like this, first all this particle, then within this gap you place the particle like this. So here you can see that this gap or the void are comparatively less compared to this one. So this define that this one is in a loose state and this one in a dense state. To define this looseness or this denseness, the civil engineer in soil mechanics have started a term or have introduced a term that is known as your relative density. Okay, what is relative density? By definition, this relative density is expressed in percentage. So first multiply with 100, and this is expressed by this formula: E max minus E natural divided by E max minus E min. Now what is this E max, or what is this E min or E net? Well, if you take any soil, okay, let's take, this is a soil. Okay, this is the soil, and here all these fine particles are here. Okay, now take the similar soil in different manner. Let's say this, here some fine particles are filling this void, this one, again here some fine particles are still remaining, and here are this particle. Okay, now again take this similar amount of soil, but here you have arranged them in such a manner that the smaller particle fills all the voids within the bigger particle. So which is the most compact soil? Obviously this is most compact. So most compact means the void ratio, you have already learned what is void ratio, that is volume of void to the volume of solid. So volume of void ratio is minimum here, and this is the natural condition. Okay, so in this natural condition the void ratio is expressed by E natural or E net. Okay, and here this is the loosest state, or the void ratio is maximum, and compactness is less compared to all these three states. So here the void ratio is maximum and expressed by E max. Okay, so by this E max minus E net divided by E max minus E min times 100, you can find the relative density of your soil. Okay, and let's say you have relative density here, and here you have nomenclature. Okay, type of soil or compactness. Okay, so there are mainly three windows in general. First one is 33%, second one is 66%, last one is 100%. When you have relative density from 0 to 30%, you will have loose soil. The compactness is defined as loose. When you have RD from 33% to 60%, then we will call the compactness as medium. And when we have 66% to 100% RD, we will call it dense soil, or the compactness is dense. Okay, so that's all regarding the coarse aggregate. And till now we have not discussed anything related to your fine soil. And in fine soil there are mainly two types of soil. First one is your silt, and next one is your clay. And in the classification, in the first lesson of classification of soil, I've already told you that you cannot distinguish, or you cannot classify this clay or silt by this grain size or this relative density like this. This relative density is related to your coarse grain soil, or more specifically they are related to your cohesionless soil. Cohesionless soil. Okay, cohesion means the property to attach with other particle. Now if you take some gravels and you stack them together, they will not attach to each other. But if you take a paste of clay and stack it with other paste of clay, they will be stuck together. This property is known as your cohesion. Okay, so now let's start how to define the, or how to classify this silt or clay. Well, in the classification we have pointed out two criteria. First one was your grain size. We have discussed a lot regarding this grain size. And second one was your plasticity. Now we are going to learn what is this plasticity and how it affects your soil property. Okay, so before knowing the plasticity, you need to learn the consistency. Again, what is consistency? Well, first one was your plasticity, but before that you have to learn consistency. What is consistency? Well, let's take some clay particle. They are very fine particle who are less than 0.075 mm. Okay, and they are in powder form. Now you add some amount of water with it, very little amount of water, and it will form a very hard paste, very hard paste. Okay, then if you again add some amount of water, it will form semi hard paste. Okay, if you again add some water, then you will get a soft paste. If you again add some water, you will get a liquid type soil. Okay, a dilatant liquid type soil. Okay, so what is the meaning of this water addition in different stage? Well, in each stage you can define the state of the paste by some hardness. Here the hardness is maximum, and here in this liquid state your hardness is minimum, or the firmness is minimum. Okay, consistency is a measure of the state. How? Well, the consistency defines how hard or soft your soil is. Okay, so we can say that consistency is a measure of hardness or softness, and it is a function of water content. Okay, you have already learned what is water content. Water content, W, is weight of water divided by weight of solid. Okay, so this is consistency is known to you now. This is a function of water content in soil, especially in case of fine soil, and which define your consistency or how hard or soft the clay is. Okay, now if you try to plot this water content with the state of your soil, let's say this is your water content and this is the volume. Okay, so initially you have some powdered clay and it was in dry form, so let's say the volume was Vd. Okay, corresponding to the dry volume of your clay potting. Then you add some amount of water which make it a very hard paste. Then again you are increasing the water content, so the volume is also increasing. Then it has become a semi-hard. Then you again increase the water content, then it has become a paste, soft paste. Then you are increasing the water content. Okay, and it has make your soil a liquid type. Okay, let's define all this water content corresponding to this change by this. Let's say when you have make your paste liquid, let's say that is WL, and let's say when you have make your paste soft, let's say this is WP. I will tell you what is WL, what is WP. And when you have transferred your paste from hard to semi-hard, that is, let's say, WS. Okay, and so this is the liquid state of your soil. This is the liquid state, and this is your soft state. Okay, this is your soft state, and this is the semi-hard state, and this is your hard state of soil. Okay, and why we are discussing all these things? Because we have to learn what is plasticity of soil to classify your fine soil. Well, you have almost reached there. This zone, this particular zone is known as plastic zone. That means the soft paste which you have made in this window is known as plastic soil. Okay, and what is this WL? WL was the limit of water content after which your soil become a liquid like. That's why this limit is known as your liquid limit. Similarly, after this point or WP, your soil has become plastic. So this limit is known as your plastic limit. Plastic limit. Okay, and after this WS, your hard soil paste has become semi-hard. This is known as your shrinkage limit. Well, in other lesson I will discuss in detail all about this shrinkage limit or plastic limit, how to find this plastic limit and how to check whether we have reached to this plastic limit or not. Okay, for right now our queries were what is plasticity, and you have got that plasticity is a state of soil when you apply load. When you apply load on it, it deforms but don't break or don't crack. Okay, for this zone in liquid level, this is a fluid, you cannot apply load, this is unstable under load. And here in hard or semi-hard state, this is very hard, and when you apply a load on it, it will deform but after breaking apart. So that's why in plastic or plasticity soil or in plastic soil, if you apply load, it will deform just like if you apply load, it will deform in this shape, but there will be no crack. This is the specialty of your plastic soil. And the index that is known as plasticity index is defined by this width of this window. What is the width? Well, this is WL, so WL minus WP. This is the window which is known as your plasticity index. More is the plasticity index, more is the plastic. Soil is the most plastic. Okay, so based on this plasticity, there are lots of properties in your clay soil which I will cover in the next lesson.